All right, welcome. Let's work number 5 from AP Calculus BC 2023 free response. Okay, so this one I haven't even looked at it. They just released questions. I just press print and press record. Right. So this looks like area volume to me. I'm liking the look of this. I like area volume a lot, and we focused on it a lot in my class this year, so I'm feeling pretty lucky. Okay, and it's got an improper integral, kind of like last year. Last year, same thing, and then I graded that problem a bunch of times in the summer. So we're going to find the area of the shaded region enclosed by the graphs of f and g. So we're just going to integrate top minus bottom to find the area of the shaded region. Okay. So, oh, interesting. They didn't give us f. Okay, so we know what we're going for is the integral from x equals 0 to x equals 3 of top minus bottom is f of x minus g of x dx. Now, because they didn't give us f, we're going to have to split out this integral. Minus the integral from 0 to 3. But they did give us g of x, so I'm probably going to want to write that out. Okay. They just gave us the integral was 10. That's convenient. Minus, okay, now we're going to have to do some calculus to get this. I'll zoom in on this guy. And so if I try to do the power rule on 3 plus x to the negative 1, I'm going to try to divide by 0. So that's reminding me it's natural log. So minus 12 natural log absolute value 3 plus x. Now, I should probably block this off so we don't make a sign error, but we're going to let x run from 0 to 3. So this will equal 10 minus 12 log of 6 minus 12 log of 3. And we are not going to need to combine those using a log property, right? This is a number that gives us the area. So we're going to be satisfied with that, and we're going to move on to the next part of the problem, right? Not going to waste any time on stuff we don't need to get credit. Evaluate the improper integral 0 to infinity of g of x squared, or show that that integral diverges. Okay, this is actually very friendly for an improper integral. The one last year, actually I think the one last year was pretty friendly too, but it was like a volume with of rotation, and you had to like get the setup right first. This one's very, direct, saying, all right, integral from 0 to infinity of g of x squared. So that would be 12 over 3 plus x. Is that how they wrote it? We're going to call that x plus 3. Okay, and if I'm going to square this, I'm going to need to square the top and bottom, right? But I'm going to rewrite this. 12 to the 2 is 144. I'm going to factor that outside. 0 to infinity of x plus 3 to the negative 2 power. So I can just use the power rule and not make my life too difficult. And so I'm going to go over here, and I'm going to say, all right, this is equal to 144. The antiderivative of x plus 3 to the negative 2 would be negative of x plus 3 to the negative 1. So, but, maybe it would be better for me to write this as a fraction. So negative 1 over x plus 3. And then we're going to let x run from 0 up towards infinity. Okay, now last year, I graded this one. And the big thing you couldn't be doing is arithmetic with infinity. You can't be plugging in infinity. But putting infinity right here was just fine. So now, when I go to think about what's going to happen as x goes to infinity, that's where I need a limit. Okay, so I'm going to have 144 multiplied by, all right, when I go to plug in infinity, I need a limit. So it's the limit as x approaches infinity of negative 1 over x plus 3. Now we can see that's going to go to 0. Minus whatever happens when I plug in x equals 0. So negative 1 over 0 plus 3. And we're almost done, but we need to be very clear that this limit is going back 0 because the denominator is growing and the numerator is stuck at negative 1. So this is going to be 144 times 0 minus, I guess 0 plus 1/3. So that's 144 over 3. But I think we can just stop there because that's a suitable answer. It's a number that's equivalent to the integral. All right, now we're going to let h be the function defined by x times f prime of x. Find the integral from 0 to 3. This really wasn't all that much area volume. This is more like techniques of integration. But I like those two. 0 to 3 of h will be x f prime of x dx. And we practice this type of integral a lot in my class. This is one that we're going to have to use integration by parts on, right? Because it's a product, but it's not use substitution. So in this class, that means u dv. So I don't have anything about f double prime. I don't have any knowledge about that. So I'm going to want dv to be f prime. So I take the antiderivative of it. So I'm going to let u equal x and dv equal f prime of x dx. Take the derivative over here, antiderivative over here, and then what we're going to do is we're going to say, all right, what we know, the formula we're supposed to know is the integral of u dv equals u times v minus the integral of v du. And if we're integrating from 0 to 3, this part of the antiderivative will run 0 to 3, and that part of the antiderivative will run 0 to 3. And so now I'm saying that this is equal to u times v, x f of x, from 0 to 3, minus the integral from 0 to 3 of v, which is f of x, du is dx. Okay, again, that little 10 that they gave us at the very beginning of the problem, that's going to be helpful. Okay, yeah, so this was a well-constructed problem. Then I'm going to plug in 3, so it's 3 times f of 3. I suppose that must be something we're able to find. Yeah, f of 3 equals 2 in the statement of the question, minus 0 times f of 0, minus a 10. So I've got 6 minus 10, that's equal to negative 4. Okay, and, whoops, you couldn't see any of that, but there it is. Okay, so that was me doing part C. And that's all for this problem for number 5. So thanks for watching.